All right, let's talk about dependent events. So multiple events are considered to be dependent if one event happening does affect another event happening. If A and B are independent events, then the probability of A and B, or the intersection of A and B, is going to be equal to the probability of A times the probability of B, given that A has already happened. So this vertical line means given that. And we can actually say that this whole piece here, the probability of B given A, is the probability of B happening given that A has happened or has already happened. All right, so independent events are usually seen in situations with replacements, and dependent events are usually seen in situations without replacements. All right, let's look at some examples. Example 1, it says a bag contains 8 blue and 12 pink marbles. 2 marbles are randomly picked without replacement. Find the probability that both are pink. So that means that we want to find the probability that we get a pink marble on the first draw and another pink marble on the second draw. So what that means is that if I want to get a pink marble, the first time I'm going to have a 12 out of 20 chance of doing that. Well, once that pink marble is picked, remember it says without replacement. That means that you don't put the pink marble back in the bag. You put it off to the side. Well, if I want to find the probability of getting another pink marble, I will have to multiply that by getting 11 out of 11 pinks that are left in the bag. And then it's going to be out of 19 total marbles. So when I do that, I will have 12 over 20 times 11 over 19. And that will give me 33 over 95. All right. Part B, we want to find the probability that a blue marble is going to be drawn first, and then a pink marble will be drawn. So the probability that a blue marble is drawn is going to be 8 out of 20, because you have 8 blue marbles out of 20 total marbles. And then you want to times it by the probability that you're going to get a pink marble, which is going to be 12 pink marbles out of 19 total marbles, because the blue one that you picked you could not replace. So now I'm going to have 8 divided by 20 times 12 divided by 19. And that's going to give me 24 over 95. All right, example number 2. A cup contains 30 popsicle sticks, number 1 through 30. No number can be pulled multiple times. If there are 3 sticks drawn from the cup, determine the probability that they are all not multiples of 3. So we're focused on not having multiples of 3s. So numbers that are not multiples of 3s, we need to list those out. When we say not multiples of 3s, that means that you cannot pick a number that can be divided by either 2 or 3. So we're going to go through each individual number and list them out. So 1 cannot be divided by 2 or 3. And when I say divided by, I'm talking about evenly. It should produce a whole number. 2 is a multiple of 2. 3 is a multiple of 3. 4 is a multiple of 2. 5 is not a multiple of either one. 6 is a multiple of 2 and 3. 7 is not a multiple of neither. Then we have 8. That's a multiple of 2. 9 is a multiple of 3. 10 is a multiple of 2. 11 is not a multiple of either. 12 is a multiple of 2 and 3. 13 is not a multiple of neither. 14 is a multiple of 2. 15 is a multiple of 3. 16 is a multiple of 2. 17 is not a multiple of either. 18 is a multiple of 2 and 3. 19 is a multiple of neither. 20 is a multiple of 2. 21 is a multiple of 3. 22 is a multiple of 2. 23 is not a multiple of neither. 24 is a multiple of 2 and 3. 25 is a multiple of neither. 26 is a multiple of 2. 27 is a multiple of 3. 28 is a multiple of 2. 29 is a multiple of neither. And 30 is a multiple of 2 and 3. So these are the numbers that are not multiples of 2 and 3. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers that are not multiples of 2 and 3. So I want to pick 3 numbers back to back that are not multiples of 3. So the first stick that I draw is going to be 10 out of 30 total numbers. So then times then it's going to be 9 out of 29, because remember, the number that I pick I cannot replace with, so it's going to bring my totals down, times 8 out of 28. So when I do that, I'm going to have 10 over 30 times 9 over 29 times 8 over 28. And that is going to be 6 over 203. So 6 out of 203 ways that I can pick will be the probability of getting all numbers, or all 3 numbers that are not multiples of 2 and 3 without replacement. So now let's look at example 3. Example 3, it says that you have a butcher shop that gives away meat at the end of each night. Each customer can only get 1 free piece of meat. Tonight there are 2 boxes of meat and they each contain 14 pieces of meat. Box A contains 6 pieces of chicken and 8 steaks. Box B has 5 steaks and 9 pieces of chicken. What is the probability that a customer randomly picks a steak from box A or a piece of chicken? So to write this, I'm going to do a tree diagram. So we have 2 boxes. We can either have box A or we can have box B. Each box is going to contain chicken or beef. All right. So customers are going to randomly pick which box they want to get their free piece of meat out of. So the probability that they're going to pick A is going to be either 1 over 2 or 1 out of 2 for A and B. And then if we look at box A, they all have 14 pieces of meat. So box A contains 6 pieces of chicken. So the probability of you getting a piece of chicken out of box A is going to be 6 out of 14 pieces. The probability that you're going to get a piece of beef is going to be, or get a steak, is going to be 8 out of 14. And if you want, instead of writing a B here, if you want to make these, if you want to make that an S for steak, that is fine. All right. The probability of getting a piece of chicken from box B is going to be 9 pieces of chicken out of 14. And then, or getting a steak is going to be 5 out of 14. So we want to figure out what's the probability of getting a steak from box A. So I'm going to use a highlighter to represent this. So you want a steak from box A. So that means you want the probability of getting steak from box A. So I need to have this. And I need to have this. All right, so the probability of me getting a steak from box A is going to be equal to and I'm going to just say the probability of AS, that means box A steak is going to be 1/2 times 1/14. 8/14, excuse me. And I'm going to represent this, I'm going to put this notation a little bit better than that. I'm actually going to write this as the probability of picking from box A and it's a piece of steak. Okay. When I do that, I'm going to have 1/2 times 8/14. And that's going to give me 2/7. All right. Part B says, what's the probability that you're going to get a piece of chicken? So let's look at the different ways that we can get a piece of chicken. So you can get a piece of chicken from box A. Or you can get a piece of chicken from box B. So when I write this out, I'm going to write it as the probability of picking box A and a piece of chicken, or the probability of picking from box B and getting a piece of chicken. So remember, write this down somewhere. Remember, the keyword and is the intersection symbol, and the operation is multiplication. If your keyword is or, that is the union symbol, and the operation is addition. So basically, if I want to say you get a piece of chicken, you can either get a piece of chicken by picking a piece from box A and it's a piece of chicken, or box B and it's a piece of chicken in there. So when I do that, I'm then just going to put my fraction. So the probability of getting box A and it's a piece of chicken will be 1/2 times 6/14. Or that means that we're going to add the probability of getting box B, and it's also a piece of chicken, which is 9/14. So when I put that in my calculator, the probability of box A and getting a piece of chicken is going to be 3/14, excuse me. And we're going to add it to 1/2 times 9/14. And you could have put it all in one line and you still would have gotten the same answer. So this is equal to 15/28. All right. Last but not least, example 4. Example 4 states that Jasmine has a bag of candy. There are 9 pieces of fruity candy and 13 pieces of chocolate. Without looking in the bag, she picks out 3 pieces, one at a time, and eats them. Find the probability that she chooses a piece of chocolate. Okay, so we're going to do a tree diagram for this one. So we have here that she has a bag of candy. So she can have fruity or she can have chocolate. On the second try, she can still pick fruity or chocolate. And then on the third try, once again, fruity or chocolate, fruity or chocolate, fruity or chocolate, fruity or chocolate. So we have to put in the probabilities here. So the first time, if there are 9 pieces of fruity candy and 13 pieces of chocolate, that is 21 or 22, 13 plus 9, 22 pieces of candy total. And the probability of getting, on the first try, the probability of getting a fruity piece of candy is going to be 9 out of 22. Okay. And the probability of getting a chocolate is going to be 13 out of 22. So if I pick a fruity piece of candy first and I eat it, then the probability of me getting another fruity piece of candy is going to be 8 out of 21 because I ate the other piece of candy. And then the probability of getting a chocolate one after I've ate a fruity piece is going to be 13 out of 21. The probability of me getting a fruity piece of candy a third time is going to be now 7 out of 20. And then the probability of me getting a chocolate after I've ate a fruity piece is going to end up giving me 13 out of 20. Because the chocolates have not been touched. So, going back to the beginning with the fruity, 9 out of 22 getting a fruity on the first time. Then we have 13 out of 21 of getting a chocolate after the fruity piece has been eaten. And then to get another fruity piece, once I have eaten a fruity piece and a chocolate piece, is going to end up being 8 out of 20. And the probability of me getting another chocolate after a chocolate has already been eaten will end up being 12 out of 20. Then if we go to the chocolate side, I'm going to try to move this down just a little bit. If we ate a chocolate piece of candy first, then that means that the fruity pieces have not been touched, which means that we will have 9 out of a 21 chance of getting a fruity one and eating it. And we would end up getting a 12 out of 21 chance if the second one was a piece of chocolate. If we were to eat a chocolate and then a fruity and then another fruity, then we would end up having 8 out of 20. And then for chocolate, because the first chocolate had already been eaten, would have been 12 out of 20. If I ate 2 chocolates first, and then I wanted to get a fruity piece of candy, then that would have been 9 out of 20 here. And then for 3 chocolates, it would have been 11 out of 20. So one thing that I need you to look at here and pay attention to is the fact that on each level here, or each branch, so to speak, or each tree, we see here that if I add these 2 fractions, I get 22 out of 22. I should see the same thing for each pair. So here I get 18 out of 21 plus 13 out of 21 is 21 out of 21. Whenever you add your branches that are connected, you should get 1. 19 out of 21 plus 12 over 21 is 21 over 21 as well. So that checks out. 7 out of 20 plus 13 out of 20 is 20 out of 20. That checks out. 8 over 20 plus 12 over 20 is 20 over 20. So that checks out. 8 over 20 plus 12 over 20 is 20 over 20. So that checks out. And then last but not least, 9 over 20 plus 11 over 20 is 20 over 20. So that checks out. So I know that my tree diagram is correct. It says, find the probability that she is going to choose one piece of chocolate. So when I find that probability, I'm finding that the probability that she's going to get the possible combinations. She's going to pick a fruity one and another fruity and a chocolate. Or she can pick a fruity, a chocolate, and then another fruity. Or she can pick, and when I say the word or, instead of writing my union symbol, I'm just going to go ahead and write the plus symbol. It's the same thing. If you want to write the union symbol first, that's fine. We can say, or she can pick a chocolate first and then 2 fruities afterwards. Okay? So when I do that, I'm going to say, start off with the first one, that she's going to pick 2 fruities and a chocolate. So when I do that, I'm going to be looking at my fruity, 2 fruities, and then a chocolate here. So that is going to be 9 over 22 times 8 over 21 times 13 over 20. Plus, we can do a fruity, a chocolate, and a fruity. So I'm going to use another color. A fruity, a chocolate, and then another fruity. So that's going to be 9 over 22 times 13 over 21 times 8 over 20. Or she can get a chocolate one first and then 2 fruities. So I'm basically following the path of the tree, which is going to be 13 out of 22 times 9 out of 21 times 8 over 20. So when I do that, I'm going to put that in the calculator. So 9 over 22 times 8 over 21 times 13 over 20. Plus, like I said, you can type it all in, 9 over 22 times 13 over 21 times 8 over 20 plus 13 over 22 times 9 over 21 times 8 over 20. And that's going to give us 117 over 385. So that is the final answer. All right. So if you have any questions on dependent events, please let me know or your teacher know, and I will be more than happy to assist you. Have a great day.